We're going to look at the Henderson Hasselbalch equation. This is pH equals pKa plus log of A minus over HA. Note that the A minus is the conjugate base and the HA is the acid. So the question is asking us, what is the pH of a solution containing 0.050 molar acetic acid and 0.30 molar sodium acetate? So we set up our expression, pH equals pKa plus log of acetate on top, acetic acid on the bottom. And so the acetate concentration is given in the problem. So we put that where that goes. The acetic acid concentration is given. We put that on the bottom. And then we would have to use the Ka of acetic acid to solve for the pKa. That's how we get this value. And then we do the math. And we get the answer. Our pH is 5.548. So let's look at a problem that we have with a buffer. The buffered solution contains 0.25 molar ammonia, and we're given a Kb of 1.8 times 10 to the minus 5, and 0.40 molar ammonium chloride, and we're asked to calculate the pH of the solution. First, we're asked to use a table and then verify using the Henderson Hasselbalch equation. So ammonia is a weak base. We react it with water in equilibrium with ammonium ion and hydroxide ion. Our problem gives us the concentration of the ammonia, so we put that in the initial. And also in the problem, we have ammonium ion, so we put that also in the initial. We have 0 hydroxide. Chloride is a spectator ion, so we're just going to ignore it. We're looking at the forward direction, so minus x plus x plus x. Our equilibrium would be 0.25 minus x, 0.40 plus x, and x. We were given a Kb, so we take the value of the Kb, we set up our Kb expressions, which would be our products here over the reactant, which is here. So we look at our table and we put in our products where they go. We put in our reactant where it goes. And then what we're going to do is we're going to assume that x is small. And so we can ignore this x and we can ignore this x. When we do that, we simplify the problem. And then we can solve for x. And then remember from our table that our table told us that x was the hydroxide concentration. So when we get the x, that equals our hydroxide concentration. We can get a POH, and from the POH, we can get the pH. So the answer that we got for our pH is 9.05. So what we can do now is simply use the Henderson Hasselbalch equation to solve for the same problem. So remember that Ka times Kb equals 1.0 times 10 to the minus 14. The Ka of ammonium ion can be solved using the Kb of the ammonia and setting it up to the Kw. And so when we solve for the Ka of ammonium ion, we get 5.56 times 10 to the minus 10. So the reason that I did this is because I can use my Henderson-Hasselbalch equation as is. pH equals pKa plus log of the conjugate base, which in this case is ammonia, over the acid, which in this case is ammonium. So this is my value for my pKa. I put that in here. And then I put my values of ammonia on top, ammonium ion on the bottom, and I can solve for my pH. And notice that I get from my pH using the Henderson-Hasselbalch equation 9.05. So this was using the Henderson-Hasselbalch equation 9.05. This was using the ICE table 9.05. They're identical. And so we verified the answer using the Henderson-Hasselbalch equation. Yeah, I think we'll do the next one next time.